Hello, my name is Alfredo Lozano. This is the final project for CISB60 fall 2025. What I did with this project was I actually decided to take the zoo data set and see if that we can compare and contrast a KNN to a CNN and see if we can predict accurately which image was a cat, dog, or panda. Uh, all right, so we go through the codes here. We go through all the numerous libraries that we did, everything from TensorFlow to NumPy, and then of course, getting the ability to import from paths and try to disregard warnings, even though they sometimes do show up. Then we go into TensorFlow regarding Keras, and we did go through with the project with the CNN at the end regarding exception with a little bit of help with the professor's knowledge regarding his project. And then, of course, we had the K nearest neighbors classifier for KNN and try to just kind of shuffle things around and try to split the data. And then, of course, the classification reports and confusion matrices. Some of this is redundant, given this was a pretty large project. And this was handled by me, and nobody else was helping at this current moment in time, but a lot of online resources, I'll admit. So let's go ahead and go through this real quick, as much as we can. So after the libraries, we go down and we have our machine learning section. Immediately, I did a direct path reference, grab the images, and then this is for handoff, but it doesn't, just to get the actual directory in case it doesn't work. We count our images, print it out, and then we start. The idea was to try to get a definition for obtaining accuracies. I don't believe that this was used, and I think I just forgot to clean this up at the end. Importing a TensorFlow, and then of course that's what we got here, just to double check. And we have, the directory does exist, the number of images, and of course the number of GPUs, which I could not get any of the CUDAs working on my machine to register with this. So another time. Then of course, grabbing our images and making sure we have full coverage with the image formats, resizing them after we flatten them, and try to get into a grayscale. And then, of course, if there was an issue, we would spit out an error. And then, of course, the end result of just making sure, because sometimes when you do multiple processes like this, you start having issues regarding was it done? Was it not done? And there was quite a few times like I stopped the process. I'm like, well, how do I know? So I do kind of like a test, like a test result if it's done. Otherwise, sometimes memory function gets impaired regarding the computer, not me, but the computer. And I don't know if it's done. I'll stop the process early. That happened quite a few times with the CNN, with the epochs. You'll see later on. All right, so regarding this, the goal was to try to grab a random set of CNNs. I decided to grab 30 with this directory, and then of course took all the categories and their numbers with all the classes regarding the cats, dogs, and pandas, and try to fix it into a plot, threw in the images and the labels into an array. And so trying to format it into 255 regarding pixel ranges, I believe that's what it was. So then I think we get like a range of like 0 to 0.1 to 1, I believe that's the correct, and then converting it to as well, because if you try to convert it into grayscale, you get like, I think it's actually here. You actually convert it here and you get this weird greenish tone. So I made sure I got the actual gray color in general by just locking it down. So we have our images, and this is kind of just checking to make sure I was able to grab random random images, and they're a little bit tiny, so I kept it at 60 by 60, I think it was, and just to make sure like, hey, the directory is awake and alive here. Okay, so now we separated between our images and our labels, and then try to grab, I tried 5 and it just didn't quite work as well. It just wasn't much going on right there regarding the K nearest neighbors classifier. And then grabbing the shapes and printing them out to show what we have and making sure everything was even, because we don't want to have an uneven distribution going on and then just this messing with everything. And then splitting of the data. And then using standard scaler to kind of just make sure everything is kind of with the same. I don't want to be redundant, say it's the same scale, but everything is just kind of like it's kind of like format, but it's also kind of like um, all the images fit to a specific way. I guess you can say that. And then we're going to fit the data and then go into the KNN and then see what we go through the prediction. Now, I kept it at 9 on this, I think. So it was pretty simple, but a pretty simple like sample set, but I think even by the classification report here, it seemed like the KNN wasn't really meant for image detection. I watched a couple of videos on YouTube with different projects. I think with Stephanie, and I think I forget my name pronunciation. It would be, well, I'll reference that at the end. But it seemed like the KNNs were just not meant to accurately recognize imagery, and so we got some, and this took some fine tuning. But it's still not perfect. You know, it's actually, it's not bad. I mean, it's not. It's like older technology, I should say. It's outdated, and I almost wonder what it would be like if before I formatted it, if I should have ran it through with RGB, and I just don't know if it would or not. All right, and then onto the deep learning section. This was okay, and then regarding the professor's information that he gave me, when I went in and tried to format everything and then separated between training and validation data sets. And then I threw this in because I needed to make sure the class names were in there. That gave me quite a bit of an issue. Um, and then I used this to auto tune. I was looking up things and regarding making sure like the CPU is processing things in an orderly fashion to its best of its ability. It's like organizing everything, but it just proper efficiency rather than jumping all around, and it kind of helped. I think at that point it actually helped with the numbers that were displayed regarding prediction and accuracy. It just seemed to do a little bit better when I did that. And before anything else, okay, the adjustments haven't been made yet. Okay, and then of course making sure things are the implementation of the training set and the validation set, and printing out the class names to make sure, because I didn't want to lose the class names and having a problem later on. Okay, and then next, if we start importing TensorFlow, and then this is where we start formatting our images, making sure our kernels are the proper number. And then I think it was the convoluted neural networks. I think that's what it's called. So we set it 64, 128, and then the pulling size, I think, was at one point where it helped a lot because a lot of these settings in general were helping out a lot because there's a couple of times where I used so much memory, especially here. The image size took up so much memory that it shut down Windows Explorer because I think it was like at 244, and then that's where there was some calibration that was just necessary. Oh, this is our neural network right here. Okay. And then, of course, making sure that the probabilities are picked up properly for cat, dog, and panda. And, oh, that's what it was. Okay, it's shrinking down to the image to find more refined details. Yeah, that helped out a lot. So this was probably the most hardest section in general because it took some calibration time. It was just like, is it going to work? Is it not going to work? I think twice I reset my computer because it was just memory was being eaten up. And then we have our model summary with all the parameters available. Then we go into compiling everything. And this is from actually from the professor. He was talking about, and this is where we get to where we start running through each of the epochs. And oh, early stopping. I can't remember if this is from the professor's example, but that helped out a lot. But at one point I stopped it because I wanted to make sure the data was efficiently running through and I wanted it to display for the presentation because I just didn't know what I was getting in the middle of the development because and calibrating everything. So it seems to be gradually increasing regarding accuracy as we go up along here. And so the validation looks like, from my perspective, looks like the loss was getting better. And also the batch size and epoch size helped out a lot because I think initially like this was like a 2 minutes per epoch and I had to stop it. But then it was, we start going along with things. This is where it was getting a little bit convoluted, and I could already see that something was going on. Like it didn't feel right. I think at one point it was starting to get like cats. All the cat images were like way more easier to be predicted, and that seemed to be the problem. And so I thought in general it was getting better in predicting the actual names of all the animals. And then I got this information and I was like, well, that seems to be doing a lot better. I thought. And the reliability of the scores and everything. And so I was going through everything. And this is where it got a little bit interesting. So, but before that, we'll just go through here and kind of not predict, compare both of them. So this is the KNN here. And, asking the professor, it seemed like it wasn't a bad thing to use, but it's completely outdated. And I think it also requires more data, like regarding like tables of data of like measurements and like sizes, lengths, and stuff like that to form patterns and then be able to make predictions. And I don't think we had that. I think we just had images. This is the CNN and seemed to be a little bit better. I believe it's the CNN. Yes. So it seemed like it was a little bit better. And then here, bringing in, I think it was I was trying to bring in the weights, I think. So what ended up happening was I wanted to do a side-by-side comparison and just keep running through this one specific cell and just see how efficiently it would randomly pick two images. Um, both are CNN. And initially it did great for a couple times, and now it's all pandas. I don't know why at this current moment of time. The only thing that I can think of is that I need to do some more changes to the training sets. And if it's not that, all the images are black and white. So I wonder if it's getting confused regarding the predictions in black and white color. So if I kept going through this in general repeatedly, it's going to keep saying panda. And I don't know why. But that wasn't a thing for the first couple times I ran this. So it is continuously just panda, panda, panda. And it seems to be opposite of what the numbers were displaying before. So I guess in reality, the 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 CNN is more biased towards, I guess, pandas, and I thought it was cats. Um, so I'm not quite too sure what's going on at this current moment in time, but I'm submitting at this current moment in time. Um, yeah, that's what I got. And then conclusions. Um, So I'm just going to read it out. So even though it seemed better at cats, it seems to be over predicting pandas. I don't know why. So fine tuning needs to be done to correct this issue, even though initially the findings were that cats were biased by the reports. Finer tuning of the training can be done to fix this, but it's just going to require more adjustments and tries. Statistically speaking, the CNN seems to be much more better at image detection, which was stated in the number of findings. But when you run through the repeated side-by-side imaging with the image detection with different classes, it's all pandas. So somehow it's more biased towards pandas. I would display the images to see if possibly like how many were wrong, but at this point I might get so many that were wrong that you might have another 5 more pages. So I am sparing that in regarding the project because I am out of time and I don't know what more to I'm not too sure what more to adjust, but I think this was given a good try. Um, Overall, though, I think regarding the algorithms in general, I think I still would pick CNN because it can handle RGB. I did try to do a checkpoint in this location here to see if I could roll back to get the color data, but it's gone at this point. I think it's just once you format it, it's gone. And I think what I would do to try to do an isolated case is throw in an additional directory of folders that are just the standard color and see how it would act and see if I would get better efficiency because I think these can handle RGBs or RGB format. And so we have our references, academic references. Some of them are I just listed because my projects that I referenced from. I think it was the decision tree and here, and then of course the CNN model that I had submitted, and then of course the professor's do classifier, and then according all the other extra stuff that I had to look for online. You'll find that in the document. It wasn't a typical scenario, so I had to like kind of stitch things together to see what I can do to get this to at least to this point of the project. And that seems to be it for now. Thank you. Oh, one last thing. Also the links for the YouTube videos. I kind of just looked over at reference. Didn't take everything, but just kind of reminders of how to do things. It was just a little bit difficult to kind of reference everything after 16 weeks. So these videos seem to help. Stephanie Powers, Farhan Aslam, particularly him, and then Tyler H was kind of some reminding on just kind of how importing images. So it wasn't kind of like referencing the MNIST database where I could just call it. This was like I had to like learn how to go into like a redundant, I think, or just do a multiple recall of images, and then go through each of the folders. So yeah. Anyways, thank you so much.